This video is really going to be a drawn-out response to some comments that were left on one of our videos. Specifically, the second episode of our 1991 Firebird series. This video was posted on January 25th of 2019, and of course, like everything else on this channel, this video is a timely response. This video covered the replacement of some small parts and odds and ends in the engine bay of our 91 Firebird. And of everything in the video, the thing that was commented about the most was my use of WD-40 when installing new valve cover grommets. The old, probably original 18-year-old PCV grommets had crumbled into dust, and we were replacing them with fresh, new ones. And to ease installation of these grommets, since they are a tight fit in the valve covers, I sprayed them with a little bit of WD-40. We were able to pop them into the valve covers, and then we moved on, and I really didn't think anything of it. Then fast forward to when the video was posted. As said before, this was in January of 2019. And as also mentioned before, here at Fuzzy Dice Projects we are always on top of things, and the video was filmed in July of 2018. So there was a small stretch of time before the video was actually posted. And when it was, there were quite a few comments regarding this use of WD-40. The more extreme of these comments reported that the valve cover grommets would very soon expire and would need to be replaced again. And before we get into any actual experimenting, which is purportedly the purpose of this video, I would like to sum up my thoughts on that. My understanding, based on the packaging and the website of WD-40, is that it contains petroleum byproducts as well as mineral spirits. And general consensus is that neither of these things are good for rubber products, especially natural rubber. I would think that the aerosol type WD-40 would be even worse, but I actually don't know if there's truth to that. At the same time, WD-40 does claim that their product is safe for use on rubber, and I have frequently heard in the past that WD-40 can be wiped onto weather stripping to help it seal again. Its use in that manner doesn't guarantee success, and if it is successful, it's probably because the WD-40 caused the rubber seals to swell. From what I've gathered, that swelling is usually reported as being temporary, and it's probably a result of the petroleum parts of the WD-40. When doing some searching, I found a fair amount of differing opinions, but there are some things that I personally do believe to be true. First is that oil, especially or specifically petroleum-based oil, does deteriorate rubber. I have personally witnessed a correlation between damaged engine mounts and engine oil leaks getting on those mounts. But this deterioration isn't immediate, and there are a lot of other factors involved, so it's a little hard to single out just one thing. And that is when I came up with the idea for this little test. So I gathered a few things, and in February of 2019 we set up a little experiment. The first thing we gathered was, well, the object that was the crux of this whole thing, the valve cover grommet. At the same time, from the same seller, we bought 3 grommets identical to the ones installed on the 91 Firebird. We took a close look at each grommet and verified that they appeared to be in identical condition to one another. To contain our pieces, we're going to be using these semi-transparent film canisters. We will be putting our valve cover grommet in a canister just as it came out of the box as a control. But before we pack it away, let's take a good close-up look at this grommet. The grommet squishes easily and quickly returns to its original form. When stretching the rubber, there are no cracks visible and the surface appears totally smooth. If we take a sharp knife to the edge, it just wants to scallop and not cut through. Basically, well, it feels exactly like you think a rubber grommet would. It's not particularly interesting, but we need some kind of comparison for our before and after. And we'll take that first grommet and drop it into that film canister. Well, really push it in because it's a little bit on the tight side, but it does fit. This canister is going to be our control. And we figured, while we were at it, why not add a few more buddies for it to hang out with. First, we'll be adding a generic rubber grommet. Just like the valve cover grommet, these are fresh out of the box and appear to be in perfect condition. The rubber flexes just like it should, and there are no cracks visible. And we'll drop one of these round hole grommets into that same control film canister. Then we'll open up another set of parts and pick out a nitrile rubber O-ring. Just like the other parts, this appears to be in good condition and there is no cracking present. And finally, we'll put in 2 small bits of vacuum hose. We'll cut one piece from a larger diameter hose and one piece from a smaller diameter. In all likelihood, these 2 types of hose are the exact same composition, but we might as well throw 2 more samples into our control canister. And we'll close off that canister, labeling it air. That will be our control sample set that we can compare our other parts against. For the next set, we'll set out another of each of those 5 pieces. We'll take a close look at each of these and confirm that, just like that first sample, they are all in good shape. Just like the control, the grommet is flexible and resists cutting. For this testing, we're not using an aerosol can, we're using what I usually use, which is this WD-40 sprayer. This trigger style bottle does not have any aerosol inside of it, so there's no extra diluting of the product. This means that there's less stuff dispersing into the air when you spray it, and it's also much cheaper to buy WD-40 in gallon cans and refill this bottle. The other thing I need to note about this is the specific formulation. This is WD-40 multi-use product. My understanding is that this is what they're calling the new, slightly more environmentally friendly version of the product. I believe this is the California legal version. For whatever it may mean, this seems to be the more commonly available version these days, and it's the version we're using for this test. We'll use our spray bottle to thoroughly coat that set of rubber parts we just laid out, making sure to roll them over and get both sides. Then we'll let them sit for a while so that some of the product will dry, soak in, and evaporate. We'll give each of the pieces a very light rub down, basically just rolling them around in a paper towel, before inserting them into a second film canister. When these pieces went into the canister, they were still a little bit shiny from the product, and they were not totally dry. And we'll set that aside because we have one more set to look at. Just like the previous 2 sets, we'll take a close look at this third set of items. They all appear to be in perfect condition, and the valve cover grommet is flexible and resists cutting. This set will be going into a third film canister and will be getting the most extreme treatment. That's because we're going to fill this canister up with WD-40. And we'll make sure the level of liquid covers all of the parts. Once everything is in there, we'll cap it off and give it a good shake. There's no perceivable leakage from the cap, so we'll assume it's a pretty good seal. This third canister will label WD-40 Soak for obvious reasons. The parts in those 3 canisters will be our 3 sample sets. We'll make sure they're all sealed nice and tight, and we'll put them away on the corner of one of the shelves in the garage. The interior wall side of the garage never gets much below freezing, but it does get pretty warm. So we'll say the storage temperature range will vary between 30 and around 100 degrees Fahrenheit. And that's where these parts have sat, mostly undisturbed, for the last 15 months. Occasionally, I would pick up the canisters and give each of them a good shake. This was mostly to make sure that everything in the soak canister was completely saturated. And after all of that preamble, we are finally here ready to take a look at our samples. First, we'll open our control, which is the air canister. Theoretically, the parts in this canister should be exactly how they were 15 months ago, or at least pretty darn close, because even in perfect conditions, everything is going to change given a little bit of time. Let's go ahead and open this thing up. I'm going to have to work to retrieve some of these things. There is our hose and grommet. If only I had some WD-40 to help get these out of the canister. Okay, there is our air setup. We have our valve cover grommet, our circular grommet, our O-ring, and our 2 pieces of hose that hopefully don't roll away. Next up, we'll open the WD-40 spray canister. These look pretty normal so far. Just like the last one, I'm gonna have to pry these out of there, I think. Oh yeah, this came out a lot easier. The inside of the air canister is still totally dry. This one still has a little bit of an oily residue on it. They look like they are in good shape. I can still see a little bit of residue on some parts like the valve cover grommet. And finally, we'll open up the WD-40 soak canister. We'll try not to spill this one everywhere. It's worth noting that this canister is less full than it was 15 months ago. Most likely that's just because this isn't a perfectly sealed canister. There's some possible evaporation leakage there, but it's still over halfway full, so I think these parts were still very much soaking. Oh yeah, leaking, making a mess already. Definitely soaking. It's also, this WD-40 is definitely a darker color than it was starting off. I thought that may have just been the plastic of the canister changing color, but now I'm not so sure. I'm just going to use an O-ring pick to fish each of these out of there. This is the valve cover grommet. I will say this mostly smells like WD-40, but it's also, I don't know, it's got a little bit of something weird going on in there. There's the color that this has turned. For the sake of comparison, we're going to dry off the parts that were soaking in WD-40. Here's where I present my hypothesis. It's maybe a little late since I'm now looking at these parts, but I had been thinking, obviously air would be, perfect or close to it. I figured the spray would also be totally fine, no issues there, but I wasn't sure about the soak. I was thinking these parts may have gotten a little hard or something, but now that I'm actually handling them and looking at them up close, it doesn't necessarily seem to be the case. First, let's take a close look at our control valve cover grommet. It still appears perfectly flexible, and it returns to its original shape. It does not appear to be any cracking that's noticeable. Feels entirely normal. It's very resistant to cutting. It kind of just wants to scallop and jump off that edge there. Across the flats here, we're looking at something like 0.95 inches. There's our control. Seems to be in perfect condition. And the same goes for the rest of the control parts. As expected, there does not appear to have been any deterioration while they were sitting around. Next up is the first of our experimental groups. We have our WD-40 sprayed parts. Here's the valve cover grommet. You can see it actually still has a little bit of residue on the surface of it. But despite all that, it sure feels to be exactly the same as our control. Doesn't really want to cut and just kind of scallops, just like before and just like our control. Other than the mild oil film surface, I cannot sense any difference between these parts. Appears to be in that same range. Each of the other 4 rubber parts in the spray canister again look identical to the controls. I don't see anything wrong with these at all. So after 15 months, the parts that we sprayed with WD-40 do not appear to be in any worse or any different condition to the ones that we just had bathing in air. But of course, this third canister is the more extreme case and maybe the most interesting. Let's see what these parts look like. Here's the soaked valve cover grommet. It seems totally fine. I can't see anything wrong with it at all. Valve cover grommet is 95. That is an interesting result. So the valve cover grommet appears totally intact. How about the other parts? The circle grommet appears totally unchanged, as does the O-ring. But when we check the vacuum hose, this piece of hose is significantly more flexible than the other pieces. And we'll have to measure this, but I think the diameter may have actually increased here. We may have gotten a lot of swelling. On the left is the control rubber hose, and on the right is the one that was soaking. Clearly, there was some swelling that happened. The one on the left, my fingers are just barely strong enough to close it, but the one that was soaking is very, very soft. Inner diameter is the best as I can measure it here with this thing. Control vacuum hose is just a hair over 1/4 inch, 0.26. The hose that was sprayed, this one appears to be 27 or 28 thousandths here. Maybe a little bit bigger. These were cut from the exact same piece of hose. I would think they would be pretty close. That may have a little tiny bit of swelling, but it feels, I don't know, maybe a little softer than the control. It feels pretty similar. And here's the one we soaked. This one is reading all the way up at 0.35 inches. That is a very significant difference in size. And the small piece of vacuum hose seems to have done the exact same thing. It's like, just gonna wipe that off and pretend that didn't happen. This is like a piece of cooked macaroni or something at this point. Inner diameter of this, 0.17 inches for the control. About 1.7 for the spray. Seems about the same, but maybe it's a little softer. It's still relatively firm. But the one that was soaking is almost up to like 1/4 of an inch. Yeah, 0.22. These digital calipers were super cheap, but these have actually, every time I've tested them against a micrometer, been very accurate somehow. It might not be accurate enough to really compare the O-rings, but I would like to try. This is the air control O-ring, 0.11 inches. The sprayed O-ring is really the same, 0.11. And the soaked one, the same, at 0.11. Here's the air grommet. I'm going to say 0.39 inches. The sprayed one, 3.8. And the soaked grommet, 3.7 or 3.8. Okay, so there you have it. What is it? What is that? What did we learn? From these observations, it appears that whatever particular kind of rubber these vacuum hoses are made out of doesn't really respond well to WD-40. I do not think spraying WD-40 on the hoses and using it to install them is going to have any lasting impact at all. But clearly, I don't know why you would, but I wouldn't recommend soaking them in it. These O-rings and grommets are nitrile rubber, and they did not seem to respond whatsoever to even soaking in WD-40. Valve cover grommets, I'm not entirely sure what kind of rubber they are. They might well be nitrile, because they don't show any signs of deterioration or change either. What I do not see is any signs of cracking or material fatigue or really any other kind of deterioration. This is the control. I believe that white on the inside of that is leftover release agent from when this was molded, and it's still visible on this one. Other than the swelling, which is a pretty obvious change, I don't really see anything wrong with the hose. Of course, if you're trying to get it to seal to something, the swelling in this particular case would be a problem, but if you're trying to expand, some old weather stripping, as talked about earlier, like T-top seals, for whatever that may be worth, there wasn't significantly noticeable swelling in the hose that we sprayed. So it clearly can make the rubber swell, for certain kinds at least. So the experiment was a success, and we learned a few things. But there was something I haven't mentioned about the original application that started this whole experiment that I think is pretty important. All the way back 22 months ago, when we were installing identical valve cover grommets on the 91 Firebird, we used WD-40 to help fit them into the valve covers. The concerns in some of these comments were that we were exposing these rubber grommets to oils that might deteriorate them over time. What needs to be considered, though, is that these valve cover grommets are going, onto the valve covers. And there are baffles inside of those valve covers, so there shouldn't be too much liquid oil splashing on them, although I'm sure there will be some, but they will consistently be exposed to some amount of oil vapor that's being pulled through the positive crankcase ventilation system and across at least the bottom surface of these grommets. Clearly, this whole thing has been an incredibly convoluted way for me to justify my use of WD-40 in that one application. Clearly, some compositions will react more than others, but it takes a pretty extreme situation to get them to behave that way. With all that said, no, WD-40 is not the most ideal solution. One option for something that was widely suggested in those same comments, and that is a silicone lubricant. Unlike WD-40, which probably won't react with rubber and cause issues, this absolutely will not. The reason I don't like this for installing parts is one of the reasons it is so good in a lot of applications, and that is that it's pretty messy and persistent and really sticks around. That means it's going to sit on the grommet and the top of the valve cover and collect all kinds of things like dust and dirt that you don't really want hanging out there. Of course, you could try to clean it off, but a lot of the things that would clean it off would be more likely to damage the rubber than WD-40 would, in my opinion. But if you have something that really doesn't want to be installed, this would offer a lot of assistance and make that a lot easier. Another great choice is a classic. Just soapy water. Just give a spray or two to a hose or something before installing it, and it'll go away on its own, it shouldn't hurt anything, and it will make installing parts much easier. This is an absolute classic, and it's what we usually use for installing something like exhaust hangers, where it can be a bit of a pain. Of course, you could also just use water on its own, but the soap adds a little bit of extra lubricity. And with that, it's pretty much all we have. We have gone through our various samples, and that's all the data we have here. Well, it's all the data we have on the table. All of these were tested in relatively controlled conditions, or at least the conditions were as close to identical as possible between our 3 samples. But I can think of somewhere else we can find a different sample in a little bit less of a controlled environment that was exposed to WD-40 even longer ago than the 15 months that these were left for. And of course, that place is right under the hood of our 91 Firebird. These are the valve cover grommets that we installed that started the whole thing. I don't really want to take a look at the one on the passenger side because it's really annoying to get to, but the one on the driver's side should be pretty simple. So let's go ahead. Should be able to just pull the PCV right out of there. Yep. And what do you know? That is engine oil. That leakage is probably due to the quite rusty valve cover that it's installed in. This grommet appears to be in good shape. I might be able to just pull it out by hand. Yep. It's a little dirty. I'm just going to wipe that off and we'll go back to the bench. And here it is next to the rest of our experiment. These are all the exact same part number and were purchased within a few months of each other. All I did after taking it off the car was give it a light rub down with a paper towel to remove a little bit of dirt and grime. It still smells mostly like rubber, but actually has a bit of a fuel smell to it, which is a little concerning for a different reason. But as far as the condition it's in, I don't really see anything wrong with it. I don't see anything concerning. It appears to flex and return to shape just like all the grommets that weren't exposed to engine bay conditions. The part inside the engine should be the worst. Yeah, it's still resistant to cutting. So, 22 months after installing it, I don't see anything at all wrong with this grommet. It's right about 95.95 inches. So it seems like our valve cover grommet from the 91 Firebird matches pretty well to all of our other samples. If only we had another vehicle with one of these grommets that had been in there even longer. And what do you know? That is exactly what we have here. This S10 Blazer has those same valve covers and the same valve cover grommets. And not only that, we installed these valve cover grommets back towards the end of 2016. So at this point, these grommets have been in here for 3.5 years. And what do you know, we installed them the same way that we did on the 91 Firebird, using WD-40. These grommets have been through pretty much a worst case scenario. This engine alone has been overheated, let's not worry about how many times, but 5 or 6 times. They've gotten very hot. This engine bay is just terrible for heat. It holds everything in. And the first time we installed them was actually on the 4.3 liter that came in the truck. We transplanted them over when we installed the V8. Let's see if we can get them out to take a better look at them. Oh yeah, that one is definitely coated. That's definitely engine oil. And there we go. Once again, we were able to remove it just by hand. Oh yeah, the bottom of this is covered in oil. These are the same valve covers, and they have the same baffles as on the Firebird. Since they're both easy to get to, we'll take out both of the valve cover grommets on this vehicle. This one is probably even worse off. You may notice the tinfoil down there. That's because this exhaust gasket blew and it was starting to melt this valve cover gasket. The tinfoil is just a little DIY heat shield. So it's safe to say that this area has gotten very hot. Oh yeah, this one feels even better than the other side for some reason, but equally as oily. We'll clean these off real quick with another paper towel, and we'll see what they look like next to the rest of our samples. And back at the bench, here we are with the 91 Firebird grommet and the two 88 S10 Blazer grommets. These are somewhere around 3.5 years old, and what do you know, they are the exact same Dorman part as all of the other ones on this table. Here's the first one, and well, to be honest, other than still being a little bit dirty maybe, I cannot feel or see anything wrong with it at all. It cuts the same way, and it appears to be the same diameter. Okay, how about the other one? This one actually feels a little bit stiffer. Oh, look at that. Is that a crack or a cut? Or it might be for me doing something stupid with it. I don't see any cracking. And it still feels pretty good, at least. It's not Doesn't feel outrageously different than the others. And we're still looking at the same size. Okay, for real this time, these are all of the samples that I have access to. And other than, I don't know, something about the longevity of dormant valve cover grommets, what is this all about? What I think it comes down to is something that's been a bit of a motto for the channel, and that's, it's probably fine. Would I still use WD-40 to install gaskets and valve cover grommets and stuff? Yes. Is it the best for that stuff? Probably not. Does it matter? Almost definitely not. If at all possible, I would probably avoid using it on vacuum hoses, but I also, again, I don't think it's going to be a problem in a real-world scenario. In the grand scheme of things, even in the scheme of the vehicle these were installed in, 3.5 years, or around that time, is not a whole heck of a lot. When removing the valve cover grommets from each of these vehicles, they were 17 or 18 years old. The rubber was clearly deteriorating and the PCV wouldn't stay in there and they didn't seal super well, and of course the most troubling part was them falling apart into the engine as you try to remove them. But it took 18 years to get to that point, and they were constantly being exposed to oil, maybe a little bit of fuel vapor, stuff like that, and a whole heck of a lot of heat. Again, I think if there's a takeaway from this video, it's maybe don't worry quite so much unless something is actively presenting a problem. For academic reasons or just curiosity or interest, it is absolutely worthy of pursuing something like this, and it was kind of a fun little project to make this little experiment happen. And yeah, this was an excuse so that I could prove that I wasn't that wrong, at least, using WD-40 in that video, but it was also an excuse to learn something, to try something for ourselves. If it says something about the result I expected, I originally planned to check in on these every other month. But now, 15 months later, I'm glad I didn't do that because there was not a lot of change. At least, not a lot that I think I would have seen over a shorter period of time, so I'm glad this whole thing kind of dragged out longer than I intended it to. Of course, I need to say that this video wasn't sponsored by anyone or anything except maybe the comments section inspiring the thing in the first place. I also hope nobody thinks this is an attack of some sort. It really is just something that I wanted to know. I wasn't entirely sure of the results. In fact, I would have expected the soak to have had a bigger effect on all of the parts. So I'm going to go ahead and reinstall these grommets before any birds poop in the open valve cover on the Blazer, and the rest of these parts will be going back into their containers. I'm going to top off the soak one, but leave the fluid that's already in there. Maybe someday we'll get back to this, or maybe 500 years from now my ancestors will find these vials and wonder why somebody took the time to do this. But for now, let's just get these grommets reinstalled. First we'll reinstall the Firebirds, and then the Blazers. You gotta make sure to really get these things greasy. I'm just not sure the spray bottle's enough. Oh yeah, that's more like it. We do go through a lot of WD-40 around here, so we should probably start buying in 55-gallon drums. Those gallon cans can barely even quench my thirst.